We may be in a situation where we have a 1 degree of freedom system, or a system that acts basically like a 1 degree of freedom system, where we have to drive the system at or near its natural frequency. And we encountered this type of problem before in system dynamics when we were looking at this from a Bode diagram perspective. We're going to look at it again here from the time domain perspective. So there may be possible solutions. We know that if we are driving a system, 1 degree of freedom system, at or near its natural frequency, it's going to have resonance and its amplitude of oscillation is going to be very large. So we have two options possibly in the 1 degree of freedom system. We could either change the natural frequency of the system, or we could change the driving frequency. So let's consider the driving frequency first, actually. So let's consider that we have a very large, tall building as the system that is going to experience oscillations or vibrations. So what our fear is that an earthquake is going to induce vibrations into our system. Now, an earthquake is going to be a low frequency oscillation, typically around 1 hertz or so. And it's going to act as a prescribed displacement at the bottom of our building, which really is just going to be a forcing at the bottom of the building. So it's going to have this about 1 hertz force acting on it during an earthquake. Now, this is a situation where we have no control over what the driving frequency is. We can't force the earthquake to go faster or slower. It's going to go at the speed, at the frequency that it desires. Now, a problem with this is if our building has a low natural frequency, which it probably will because it's going to have a lot of mass to it and it's going to be pretty stiff. So it might have a natural frequency down near the 1 hertz area. So a 1 hertz input from an earthquake is going to really be amplified, and the oscillations could be very large in the building. So since we can't control the driving frequency, can we change the natural frequency of the building so that an earthquake is going to affect it less? Well, probably not. If it's going to act like a 1 degree of freedom system, then the mass of the building and the equivalent spring constant of the building are going to determine its natural frequency. In the 1 degree of freedom system, root k over m is going to be the natural frequency, so we could maybe change the mass of the building. However, the building is going to have so much mass that to have any appreciable change in the natural frequency would mean adding a lot of mass to the building or removing a lot of mass from the building, and that's not likely going to be possible. Alternatively, we could change the equivalent spring constant of the building, but that's going to be dictated by probably the height of the building, the material that the building is made out of, and so forth. So changing the effective spring constant of the building is also probably not viable. So it looks like in this case where an earthquake could cause oscillations in our building near its natural frequency, there's nothing we can really do about the driving frequency, and not too much we can do about the natural frequency either. So it appears as though we're stuck. If an earthquake hits, we're going to be in a lot of trouble. But there is another technique that we can use to change how the driving frequency and the natural frequency are going to interact. So what we can do is we can add a second mass spring system into our building. So effectively what we're going to do is we're going to change our 1 degree of freedom system into a 2 degree of freedom system. And what we know from earlier in this section is that 2 degree of freedom systems are going to have 2 natural frequencies. But the calculation of them is going to be based on the interaction between this vibration absorber, we're going to call it, and the main building. So it's going to shift. The new natural frequencies are likely not going to be located, either of them located where the original natural frequency was when it was a 1 degree of freedom system. So it looks like we complicated the problem that we had originally, and in some ways we did, but by choosing the mass and the spring constant of this vibration absorber, we can tune our now 2 degree of freedom system to have its 2 natural frequencies away from the driving frequency. In this case, if we're again concerned about an earthquake, we could have those natural frequencies as far from that 1 hertz driving frequency as possible. So what we're going to see happen is that when we analyze now the 2 degree of freedom system and where its resonance is going to be and where it's going to have low amplitudes, by putting in this tuned vibration absorber to avoid a specific driving frequency, we're going to see basically a notch filter or a very narrow passive band stop filter in our system.